Well, hello everybody. Welcome into Great Atmosphere here on this Tuesday edition, March 12th of 2024. Want to apologize real quick for not getting those videos out to you on Friday or Monday. Wife was sick on Friday. I was subsequently sick on Monday. Just couldn't make that happen with the schedules and subsequent antics that we had to endure for that time period. But I wanted to make sure to get a Tuesday edition out to you this week because we got quite a severe threat on deck. For the latter portions of the week, quite a lot of exciting stuff to talk about. So we will talk about that severe threat today. We'll go pretty in depth on the severe risks, particularly those on Thursday and Friday of this week that we're looking at. We'll also take a quick look at the rare enhanced snow event that's going to be occurring across Wednesday and Thursday across the Front Range of Colorado. And then we'll begin with a quick look at our meteorological winter starting in November of last year all the way through February of this year and see how it stacks up according to the NCEI particular database of both precipitation and temperatures. So we're going to get into all that, but before that I just want to encourage you to subscribe to the channel. Here at Great Atmosphere we focus mainly on the southeast United States, but of course if things aren't going really, there are not a lot of exciting stuff to talk about in the southeast. Obviously we'll expand our horizons out into other parts of the U.S. and even the world if that just happens to be the case for the day. Had quite a few new subscribers for a lot of the recent videos I've put out, so I appreciate the newcomers for coming onto the channel, and I do so appreciate your support. So we will get started here by looking at the divisional precipitation anomaly for the month of, or actually the time scale is 3 months for precipitation across the contiguous U.S. So what this essentially shows is how wet or dry that the contiguous U.S. was, of course, across the entire course of winter, and how that stacks up. I believe the data set goes all the way back to 1930, so almost 100 years of data in this particular set. So you can see that it was a particularly wet winter across the Carolinas and the Virginia Piedmonts. A little bit of a dry spell in eastern Tennessee and western Tennessee and western Kentucky into that upper Mississippi River Valley region. Generally wet across the Central Plains. Dry, and this is, and a lot of people will be like, "Oh, was it really dry across this particular region of the upper Rockies?" Well, no, it wasn't. It was, it's a lot of this has to do with, people forget that in the beginning part of the winter. It was quite dry out there, and that kind of skewed the results. Remember, this is across an entire 3-month range, so even though I know in the in the Northeast for the most part, it's been very dry to begin 2024. People forget that there was significant flooding events that actually occurred across New England and the Northeast to begin in early December. So those kind of things skew it. So that's just kind of a little grain of salt you got to consider in these. And then obviously we had significant atmospheric river events across the West Coast that were particularly difficult to forecast. And then we had across the Gulf Coast, it was generally more wet due to the southern jet stream, the subtropical jet stream that was pretty much going across that area in southwesterly flow direction for the majority of the winter time. And we can see how this stacks up in terms of what the NOAA CPC, Climate Prediction Center, predicted going into the winter. They were predicting a very above average. They were predicting that subtropical jet to be screaming across the deep southeast into the Florida Panhandle quite significantly. I think that verified pretty well. Excuse me. And then they had a little bit of a dip of this little dry tongue across the Great Lakes states that you can see how it kind of pushes down into that upper Mississippi River Valley region. You can see that actually verified quite well. The only thing it did not necessarily get in, we had quite a few streamers that went across the northern Illinois and northern Indiana, southern Michigan region, across mainly in the latter portions of February. Before that, it was quite dry. So I think they did an overall pretty good job in that regard. Got the upper Mountain West pretty well. The only thing that they kind of missed on in this regard is they did have above average for the West Coast as a whole. I would say mainly in the California region. It's just so hard to because it's hard to forecast for the West Coast, primarily because out in the middle of the ocean, there's just not a lot of meteorological stations for us to draw a lot of information from. So they have to go strictly off of climate modeling and historical precedent And whenever something, relatively crazy happens, like a multimodal atmospheric river event that occurs over the course of months, not something that we're normally used to seeing, it is not necessarily something that is very easy to predict on their part. So I think by them getting an above average precipitation rate for this particular region, I think is probably the best they could do in that regard. Then we take a look at the temperature anomaly for the winter time, and you can see we've talked about this on the channel quite a bit, but this was the warmest winter on record for the areas that are highlighted here in dark red. So Minnesota, Wisconsin, Iowa, upper parts of Michigan, and even parts of the Northeast on the upstate of New York, Vermont, New Hampshire, they were all well above 9 degrees higher than normal in terms of average temperature. It was another winter that never came for those particular regions, and there's a lot of people that definitely know what years those are, because most of the time those years were succeeded by a summer that was particularly dry. Some of the worst droughts came from those winters that never came in the past. I believe that last one was 2012. Another famous one was 1983. So there were a little bit of a concern in the future for these particular regions, according to that. And we can see that overall the CPC was generally on point as a whole. It was across the entire U.S. it was above average. You can see, with some exceptions in the Florida Panhandle where they were just technically average. Everywhere else was technically speaking above average. And for the most part, you don't see any below average across the contiguous U.S. In fact, they even had a lot of confirmation that it was going to be normal in a lot of respects across the southern plains, and they were largely, within a 1 to 3 degree factor, pretty on point with that. So hats off to the Climate Prediction Center for their seasonal outlook. We can also take a look at the regional Haywood model here. So this is our precipitation as it has happened over the past 12 months in relation to, I believe, over 130 years of data here. So particularly, we're going to look here at the southeast. In terms of where we sit currently, we can see at 2024, where our current climate period that you see the mean average here across the southeast as a whole sits here on this black line. And the blue line, for the most part, kind of models where we have been over the course of the past 12 months. So you can see for precipitation here in the southeast, we are largely right on track. And we can see with temperatures, it's a little bit different. Here we are highlighted by a green line, and the mean is still a black line. We were generally on the same temperature track for the mean average until we got to the summer of last year, and then El Nino started to kick in. And we've been, generally speaking, quite above average to begin the year so far across the portions of the southeast, going in from April last year to March of this year. So generally speaking, an already quite warm start to the season, not an unprecedentedly warm start to the season by any means. That takes the cake from 2020. That was the overall. But as far as right now, the warmest ever was 2017, actually, across the majority of the mean southeast. And of course, you can take a look at this online from the NCEI website. You can even get down to as far low as a resolution down to your particular city as well. So I'm just looking at the southeast as a whole. It would take me days to go through all that data. It's been very fun this morning to kind of look and see where everyone kind of stands. But I just want to get a quick snapshot of the southeast. We can also take a look quick at how the snowfall has sorted out itself over the past 3 months. This starts from the season beginning, so this is all the way from October all the way until now. So a lot of white here in the southeast, no snow for the most part across the majority of the Carolinas, Georgia, only the northern regions of Mississippi, Louisiana, and Alabama. Had some significant snowfall here in the depths of the Ozarks, and a little bit of lake effect snow from some of the Dallas reservoirs that exist in that particular region of northeast Texas. But for the most part, it's kind of crazy that, areas of Tennessee got the same amount of snow that, the portions of central Minnesota did. Minnesota got barely any snow in relation to what they normally get. And then you can see across the higher elevations in the Rocky Mountains and the Upper Mountain West and the Pacific Northwest and the Cascadian Range, they got quite a bit of snowfall over this year. Definitely a lot of snowpack to be had. I'm sure a lot of the farmers coming out of the Front Range and down into the Central Plains. We'll certainly enjoy that going into spring planting season. But of course, not a lot to write home about in terms of snowfall. I believe the southeast, probably from points Raleigh southward, have experienced no snow. They have not experienced any snow in this particular region for over 2 years now. The last major snow event, I believe, was in January of 2022 at this point. So it's been over 2 years. Weirdly speaking, that is the longest that the area has ever experienced without receiving even a trace of snow. Usually we get some kind of winter precipitation, just like a little bit to kind of keep the record going. But it's been 2 straight years of not having any winter precipitation recorded in any of those regions. So if you like snow in the southeast, has not been a great couple of years for those folks. And you can see that actually this is a chart put together by Ben Knoll. Ben Knoll, originally of, I believe, AccuWeather, and then I believe he moved to New Zealand actually, but he was still at the time known for kind of being the guy who would tell you whether or not you were going to get a school delay if you lived in the Hudson River Valley of New York. And he's still quite known for that actually. I believe his website is at benknollweather.com. It still references that. But you put together this chart to kind of show the December to February snowfall in the contiguous lower 48. And 2024, technically speaking, was the least snowy winter across the lower 48 states in history, going back to when the record started back in 1940. And this is according to the Era 5 model as well. So interesting little tidbit there that we're not that particularly snowy, and he attributes it, of course, to El Nino, record warm global ocean temperatures, and warming air temperatures across the contiguous U.S. was the primary drivers for that lack of snowfall. So we'll get into what we've been looking at here across the states over the past week. Quite a bit of precipitation across the eastern seaboard and the eastern half of the United States, in addition to the Cascadian Range. This has kind of been our significant drought buster. Any areas, particularly across the Mississippi River Valley, with the exception of maybe the western portions of Tennessee that we mentioned earlier, a lot of drought busting has been going on across here. It's been really good. We do not want to go into the summer, where we could experience maybe a little bit more drying out across the majority of the central U.S. Without having kind of getting as much precipitation into the soil as possible before we go into it. So we had quite a bit of rainfall across Georgia, Alabama, Mississippi, and then this extended all the way up, and then New England got quite a bit of precipitation as well. Of course, this is according to the MRMS National Radar assessments. Not a lot to write home about, unfortunately, in Minnesota and Wisconsin and the upstate and the Dakotas, or in Wyoming and Montana. Hopefully, as we move forward with our pattern that we're going to be describing here in a couple of minutes, they'll be able to get a little bit of more precipitation out of this, and who knows, maybe a little bit more of the wintry stuff before we fully move into our transitional season of spring. And we can actually see just how the last 30 days look by percentage of normal, or compared to percentage of normal. We have been generally above average across the eastern seaboard, with the exception of the Mississippi River Valley as a whole. This is the primary concern, right? So and these are the reasons that you've seen a lot of fire weather warnings around portions of the north, central, and southern plains. It's just been exceptionally dry, so it's a lot of fuel out there. We get a lot of downslope flow whenever we have systems come across in the transitional seasonal periods. So it is quite windy. So whenever you have a lot of fuel, you have a lot of wind, and you have warmer than average temperatures, and obviously not a lot of moisture. You get pretty much prime fire weather, and that's what has unfortunately been ongoing here, particularly with that Smokehouse Creek fire and the panhandle of Texas that has burned over 1.5 million acres. That's just the end result of what's been occurring. But fortunately for us in the southeast, that has not been an issue for the past month or so. So taking a look at our current GOES satellite view, you can see it's generally very calm weather across the majority of the states. But the main story will be how this incoming this incoming little trough is going to affect us here across the southeast, and it's currently moving into the Pacific Northwest as we speak. Now, this is what is the main driver for our weather going forward. This is looking, I believe, actually I can, let me double check where we're at right here. So this is 3:15. So this is later on in the week. This is on Friday. And this is what we commonly refer to as an omega block in just Meteorology 101. If you know your Greek letters, omega kind of looks pretty much like this. It has a big high pressure center in the middle, and it is bookended by these two cut-off surface lows. And when that occurs, it is generally quite difficult for the atmosphere to get this out, to kind of obviously move it away. So that's why it's referred to as a block. And what are the end results of it? We usually get more mild and dry conditions in the middle where you see that high pressure center to be. And then in these surface lows that you see, we generally get more cooler air, and we generally get a little bit more moisture as well. And this is highlighted by the National Oceanic and Atmospheric Administration here in the omega block. It pretty much describes it as that. Omega block's quite persistent, can lead to flooding, drought conditions, depending on the location of the pattern. And that's pretty much the end result. And it's just quite difficult to move this out just because it is such a large pattern in these regards. And the ultimate hope in this regard, in this matter, is that it does not stay like this for long, just because any time that anywhere stays under the same weather pattern for a consistent period of time, whether it be both drought or moisture, we want to achieve some kind of homeostatic balance. And whenever we're in a blocking pattern such as this, as we are predicted to be later on this week, we generally are not a big fan of that. So before we get into that, we'll talk about the All Hazards Index here. The next big system that will be coming out of it will be the major Colorado snow event. We see our fire weather and wind warnings that are going across Minnesota, Wisconsin, and West Texas and New Mexico. In addition to that in Georgia as well. So we'll take a look at what that looks like, particularly here, and what we're predicted for snowfall over the next few days. This is going all the way out 72 hours. Looking at the probabilities, this is probability of receiving more than a foot of snow. So the primary centered regions that we're looking at here would be in the southern Boulder regions, Denver as well, quite under the gun. Anywhere along the general northern front range, even extending down here into the Sangre de Cristo Mountains, we're expecting a little bit more. It's all going to be isotropically and topographically elevation-based snowfall, because we're going to be getting upslope flow from the easterly direction, and that's going to be the primary driver of this particular system, just because we're going to have cold air that is currently sinking down as we speak aloft. That is going to be sinking down on the surface, and then eventually, once that easterly flow comes in, as that surface low starts to move from Southern California and up and into the Central Plains, the flow pattern will evolve and move straight into Colorado, and we are going to be able to see that in the NAM guidance that I'll show you in just a second. But taking a look at the probabilities for each of these particular, we can go all the way up here. We have a 40% chance of receiving 2 feet of snow across the portions of southern Boulder. Even let's go up to 30 inches just for some fun. Yeah, we got 20 to 30% chances of receiving over 2.5 feet of snow, and of course that's just as high as that goes. But looking across the region for just 4 inches, I mean, like a 90-95% chance across Denver to get 4 inches of snow. 8 inches is still quite significantly high across this. And this is kind of like what happens. Late season El Niños typically create giant snowfalls across the Central Plains. This is a very common occurrence. It's been actually been predicted quite well by people for a number of months that we are going to experience a little bit more snowfall in the North Central Plains and along the Front Range of Colorado, Wyoming for this particular region, because we do have that subtropical jet is still going to be going strong for as long as El Nino persists. But also, we saw that resurgence of the polar jet that we've been seeing for the past couple of weeks. It's since merged again. You can see that there is some semblance of it still over Russia and China, and it merges off the Japanese archipelago, creates quite a significant streak. And then typically, actually, what happens is we get a high over low setup. That's what we've had for the majority of the winter. That settles over both the Canadian Prairie for the high, and then pretty much where that surface low is as the low. And that kind of created our atmospheric river events that we've seen over California and Oregon over the course of the past winter. The only difference is now, as the transitional period starts to come into more full effect, that warm sector starts to kind of push further and further north, and thus has a heavier influence on those subsequent lee side lows, which is kind of what's enhancing this particular region here in the Four Corners area, and creating that cutoff low and subsequent omega blocking pattern. So that is kind of what we've been looking at, and they're kind of right on, and so far everything's been right on the money in terms of the forecast. We'll see how much it verifies. You can take a look at the German icon model to see what the current true snow to liquid ratio they're predicting out of it. Some 20, 19, 10, 17 inches, primarily along the higher elevations of this particular region across the majority of that period. So it'll be quite interesting to see what those totals end up verifying as, and we can see that looking right now at the NAM 3 kilometer. If we can get this to load real quick. So let's take a look at what the 3 kilometer NAM is currently looking at in terms of how this system particularly progresses going into the rest of the work week. So we have the majority of that troughing start to sink into the portions of the Four Corners states, creating some snow up in the higher elevations. Not really activating anything so far yet into the Mississippi River Valley and points west into the Ozarks. It's just when we get that center of that surface low starting to form across the Four Corners is when we start to see a lot more of that. We can see where that low center is obviously is forming right here, starting to kind of open up a little bit more of this sector, but ultimately it'll start to wrap around, and the ultimate flow will start to come out of the east. And when that occurs, and we get moisture coming in from the Gulf and the southern portions of the subtropical jet, is when this really starts to kick off here for Colorado. We'll start to receive a lot more of that cold air. And remember, as this low starts to form and tighten up, it's drawing in a lot more cold air up and down from the upper Rocky Mountain Plateau, and at the same time drawing in more subsequent moisture in from the Gulf as well. And with higher elevations, obviously this is the Rocky Mountain Front Range, you get a lot more of that isentropic upslope wind effect that is going to create some havoc as we get for the Colorado region. And you can see this really starts to progress and kick off according to the NAM, and this starts in earnest probably Wednesday night at 5 to 6 p.m. and begins to go straight on into the remainder of the day, into Thursday as well. You can see it's just pretty much blue across the majority of the state of Colorado, even kind of peeking out into far western Kansas. And even so, we expect this entire area pretty much in points across like here to kind of be in this cold plunge, because all of that Canadian prairie air that's been kind of sitting across the cold continental air mass is starting to get enough forcing to bring it down south, which is very typical for this time of year in a post-El Nino setup. You can see it's quite significant, the amount of snow that we're going to be receiving there, and as that surface low obviously starts to move even further and further to the west, we get more flow coming out of now the northeast, but it starts to really open up the Gulf, and we create and along the warm front is where we're going to be seeing a lot of severe convection as well. Probably at points south as we go forward. The NAM 3 kilometers just doesn't go out that far, but you can see the beginnings of that convective initiation across portions of southern Iowa and northern Missouri as we get into latter portions of Thursday and into Friday. And we can take a look at what that looks like according to the AI model from the Euro as we go forward in time. I believe I just got to get my buttons correct here for Pivotal. Yep, so let me let this load here for a second. So this, generally speaking, is just a little bit slow. Give me one moment. Okay, so we start the day with having a little bit of a shortwave come through Colorado that's going to make its way off and into the Ozarks as we go forward in time here. And you see this little perturbation right here. That's going to be the primary driver for our slight severe threat going into Wednesday and maybe even a little bit tonight, because that is going to be ultimately just this tiny bit of initiation that the area needs to get just a little bit of the forcing necessary to kick off a lot of the instability and a lot of the moisture because remember, we are kind of just sitting in that warm sector here across the majority of the southeast and southern central plains. That is going to kind of be a little bit of a driver going into the next 24 to 36 hours, that little perturbation there. But we get ridging out in behind it. That's going to open up this area quite a bit to some more moisture, some more upper level moisture, or I said mid-level moisture, sorry, and then some warmer temperatures as a whole, creating a good bit of instability across the area. We just don't have a major forcing mechanism across the southeast to really kick off any of the thunderstorms, because the major forcing mechanism is back here. We can see that low center is going to start moving down and deepening, and officially cuts off fully. You can see how it cuts off, and it obviously cut off low by definition. Excuse the pivotal antics here as I try to get to my pen. So you can see, obviously, the telltale definitions of that mid-level cutoff is just because the low is concentric and circular right here, and the overall flow pattern of which what it was originally attached to is, generally speaking, way up here in the plains. So it's just going to kind of sit here and spin over and over and over again on itself. And how long it stays is kind of up to other climatological forces at work that are going to make this push over the course of time. So, and we'll move forward in time just to see how long that particular item, that low center, lasts. And you can see this is all the way out into Saturday, so I don't want to get too far ahead of myself here, but that primary upper level low is going to sit there and spin across Southern California and Arizona and the southern Baja of southern Baja California and Mexico, and it's just going to keep on drawing a lot of that that moisture up from that subtropical region, and we can just see it pull in like this all the way up and in. And then at the same time, it's going to keep a lot of more mild and dry air across the Pacific Northwest. And the end result at the surface is that it's going to ultimately kind of create that surface low that we talked about, according to the NAM, right in here. And that is kind of going to be the main propagator for our severe weather going into the latter portions of the week. We'll see how this looks going forward in time, and just see how long that surface cutoff low stays there. You just kind of go and see. It's still technically there as we go into the middle of next week. Now it's significantly weaker, and this is of course according to Euro AI model, which is a quite new set of data that meteorologists are still kind of wrapping their head around in terms of where it sits, in terms of how we should respect it. Is it an ensemble? Is it AI machine learning? Like what is these are kind of the modern day decisions that need to be made, and a lot of research still needs to be associated with it. But I still want to share that with you, that this is obviously this is cutting edge stuff. So just kind of be mindful of that. It still has the omega block generally still there, but ultimately weakening as we go forward. Probably about a week that this ultimate system starts to kick in. We have our main kicker that sinks down from the Canadian Prairie and the Hudson Bay. That will kind of deliver us a good cold shot of below average temperatures in the middle part of next week that we'll get to at the very end of this video. But that's ultimately going to be the main driver on Thursday and Friday. You see this broad southwesterly flow, and I've talked about this at length on the channel. Anytime in the spring that we get broad southwesterly flow, when we have, generally speaking, more cooler air. Anytime we get more cooler air here and more warmer air here, the kind of disparity, that is ultimately going to be our primary component for generating a lot of severe weather, because anytime that you get mixtures of both cool and dry air mixing in with warm and moist air, and then you get a forcing mechanism on top of that by way of like a shortwave trough like earlier in the week, or we get our cutoff low that kind of precipitates a lot of diffluent flow aloft, that is going to be those are the things we look for in terms of generating our transitional season severe weather events. So we can take a look at what that looks like in terms of our 500 millibar map from a relative vorticity point of view. And remember, vorticity is kind of like the energy that the atmosphere needs in order to kick off convective initiation, whether that be frontogenesis or any kind of mechanical lift. That is going to, anytime that you see these ribbons of energy that are both either bright reds and dark grays and blacks right next to each other, is where the atmosphere at least is at least primed and ripened for some convective initiation. So as we go forward in time here, this is Wednesday afternoon to Wednesday night. Going forward here, this is about Thursday night, and you can see that generally speaking, we get quite a bit of variation here in this northern sector. and then we'll kick off even later, more in the Arklatex, Arkansas region and western Tennessee as we go into Thursday night into Friday, and even more so across portions of the south. Now you see the big cutoff flow here, just because that area. Remember, this is the 500 millibar map, and that is a cutoff low. I wouldn't expect the difluent flow is going to be over and above the high topography of the Rocky Mountains. So while it does seem, and don't get me wrong, there will still be a good bit of precipitation over this region. I don't believe it'll be anything obviously severe due to the influx of dry air and that occlusion that we're expecting there in the mid levels. It's ultimately this southwest flow that's interacting with cold air here. That's going to be the main point of contention going forward. And you can see how that flow pattern kind of interacts here. So I just want to point out with you here. So we have the cold air coming down from here, and then we have just strong, warm and moist air being ripped across here. And then, of course, this is in the upper level, so the surface low is going to be kind of pointed right here, and it's going to be kind of going in this direction. And so anytime that anywhere out in this kind of conal area like this, this particular region is going to be under the gun for some kind of severe threat. And we're going to be taking a look at that real quick. So the SPC has outlined here, of course, this is looking at Thursday into Friday, a generalized slight risk with primarily two general modes here, multimodal. So we have a northern mode, northern sector here across northern Missouri, Illinois, and Iowa, and then we have in the Arklatex region of southeastern Oklahoma and northeastern Texas in the DFW region, and in the far, of course, this is all under a marginal risk, but of course the slight risk is what we need to focus on the most. And it's generally in the terms of a probabilistic standpoint, you can see more clearly those two particular modes. This is currently the day 3 outlook, so it's not going to be categorized according to what the particular threat is, so it's the all hazards index at this point. But anywhere in the hatched areas where we would expect to see a significant severe event, or a 10% or greater probability of significant severe weather within 25 miles of a point within any of those hatched regions right there, particularly in that Arklatex region and in points of the upper Midwest. So let's take a look at what this currently looks like on the 500 millibar wind speed map with geopotential height lines. So we take a look. This is on Thursday night going into Friday morning, but we're going to kind of back this up a little bit, excuse me. So anywhere that we see these higher jet streaks available is where we would see kind of more convection aloft, more divergence aloft. That's going to be kind of our major factors in creating a little bit more of a convectively unstable environment. So we see a lot of that going on in the northern Missouri, northeastern like near Kansas City, and portions of southern Iowa and northwestern Illinois. That would kind of be our northern mode to this particular system. But overall, we see it's kind of a whole area kind of open up as that low center starts to sink a little bit further south. More southwesterly flow kind of just comes on in from the southwest, and ultimately kind of opens up the entire sector to a little bit more of a convective available activity. We can take a look at what the surface temperature map. There's been a lot of disparity between a lot of the models in terms of how severe this kind of surface low that we expect to form here in the northern mode to kind of start to wrap itself around. The NAM was quite bullish early. It's kind of laid off that recently, and then conversely, the GFS and the Euro flagship models have kind of done the opposite. So we can kind of see what the NAM kind of looks like here. We can see that ultimately that we have a good significant gradient. We have 38 here. We have 74. Here in central Missouri compared to 38 here in the far southeastern regions of Nebraska. That's quite a significant gradient, but there's just not a lot of tightening. We can see surface lows kind of just trying to pop up in different areas as we go through the period. There's not a lot of concurrency that shows that there's going to be a lot of tightening with this particular system in the surface low, at least according to the NAM right now. But conversely, we can see what looks at the GFS. We can see a much more tight signature there, and we look at the Euro, and that signature kind of exists there as well, although the gradient of temperature is just not as severe as what the NAM is currently putting out. So we can take a look now at what bulk shear looks like as well. So this kind of illustrates just how much generalized instability the atmosphere generally has. And this particular area, it's areas of these bulk shear where we get bulk wind direction shear knots are going over 40, 50 knots is where we'd expect to see quite a bit of divergence aloft. And that's where we are kind of expecting for this mode to kind of really start to kick off in earnest. And then we can take a look at our geopotential height according to the NAM here in terms of our low-level jet. The low-level jet is kind of kicking off across the entire sector that we are expecting to see this. So areas from eastern Texas all the way up and into Iowa, this kind of generalized region right here, excuse my click, that's going to be our problem area going into the mid-afternoon into the overnight hours on Thursday. We can also take a look at the overall instability profile. So we can see we have huge cape values. This is, of course, is mixed layer cape going all the way up 3,000 joules per kilogram of convective available potential energy. Quite a lot of thunderstorm fuel as it is for this particular system. So we have big buoyancy, we have strong vertical shear. So typically when this happens and it's all into kind of the warm sector, we expect to see more of a supercellular mode to this, kind of creating that all hazards threat. I would say, mainly because where that warm frontal boundary is, that's going to, and the differentiation between and low level wind shear, that's going to be where we would kind of see our problem areas for more of a tornadic threat. But I would say, depending on what we look at, I pulled a couple soundings just now, and this is kind of for the southern mode sounding. So we can see here we have quite a significant elevated mixed layer all the way up to the 850 millibar level. So moisture is going pretty high up into the atmosphere here. We also get pretty deep instability. Once we get up to the 850 millibar level, we have cape levels that just kind of balloon. So surface cape, we have 2,500, mixed layer at 2,000. Those are significant. Not a lot of convective inhibition with this too, so the cap is going to be quite easy to overcome. The main thing with this, though, is we have very limited low-level wind shear. You can see we're only getting shear at 5 knots, maybe 3 kilometers to get up to 40. But I mean, this is just one particular sounding I pulled from a convective model in the or from the NAM. So this is in that southern mode. I think the most interesting part of this is this area right here. So this is the freezing. I got to change my pencil color. So this is the freezing layer, so 0 degrees Celsius. Anytime that we get a significant mid-level lapse rate, kind of greater than 7.5 degrees Celsius per kilometer, we have 8.3, which is quite significant in that itself for a lapse rate. But we also have that's in the freezing layer is right in the middle of that. This just screams. It just screams big hail event. So that would be kind of what I would expect once the SPC kind of gets into the day 2 outlook to kind of highlight more of a severe hail event in this particular scenario, because of that deep instability and being right in the middle of the freezing layer. And then we take a look at the hodograph. We have strong deep layer linear shear, but there's not a lot of curvature to it. You know, this is more conducive to a supercellular kind of outset. You know, quite significant up UP right there, but I would say this is more of a severe, a supercellular kind of mainly a hail threat. Obviously, can't rule out an isolated tornado or severe winds and whatnot. I believe wind is going to be a major factor on the backslide of this if this develops more into a QLCS as the surface low starts to wrap around on the back end. But at least as from a discrete supercellular point of view, out in the warm sector, hail is definitely going to be a primary concern moving forward with this particular system. And we can take a look at the southern mode. Southern mode's a little bit more interesting. Excuse me, this was for the southern mode that I was just talking about. My mistake. But the northern mode is where we see more of that shear, and we can see that curvature in the hodograph. This is due to that warm frontal boundary being in place. Particularly, we have this is a sounding I took was taken ahead of the surface low and north of the warm frontal boundary. We have dew points that reach the lower 60s, 64 over 61. You know, that's a very favorable convective outlook right there. But we get significant low-level wind shear that we see right here, and that's going to be a major player. So we have the surface to 1 kilometer, 27 knots, 3 cape at 43, generalized cape throughout the course of the entire profile. This is definitely more of a tornadic event. Now, this actually was upgraded quite a bit from earlier on. They weren't expecting. I mean, I pulled soundings from yesterday, and they were not expecting this kind of a tornadic threat. So I would say, and definitely look at these lapse rates here in the mid-levels, right in the middle of the freezing layer. So I believe it's starting to look more and more like a more significant severe threat according to the NAM. That's primarily driven by the tightening surface low and a little bit more of that temperature gradient that we talked about before, in addition to that low-level jet bringing more moisture and being kind of met with a strong area of cold continental air mass up in the northern Canadian prairie that's going to be advected down due to that cutoff low kind of moving stuff around in the upper levels. So This generally could be bad news for that particular region in the northern mode, but the southern mode, I would say, it's primarily it's still all hazards. You can't rule anything out, but definitely more of a hail threat compared to the northern mode. So that's just my own particular take in that regard. And maybe take a look at some fun stuff like this is the Colorado State machine learning model. So they're taking a look at their atmospheric science department is taking a look at some of the day 3 tornado probabilities. You see, and this is kind of all the stuff that we got to take everything with a little pinch of salt. Everything's going to be different, so they have more of the hail probability up in the northern mode, but of course it extends all the way down. This is of course their AI model, and they're saying a little bit more of a tornado chance in the southern mode. Wind probability, it's definitely something I agree more on as that QLCS starts to kind of make its way and wrap its way down. If the surface low kind of exists, excuse me, I got to change my pen again. If the surface low kind of exists right here, the cold front will kind of extend down here, and then the back end flow will start to move in and create a much more significant downdraft wind event. And I didn't really get a chance to look at DCAPE. Ooh, yeah, DCAPE at 632, so that's going to be quite significant for both. We're at 500 there in that particular mode. So yeah, I think straight line winds and hail is kind of the sure thing with this particular setup. And then we're going to have to really keep an eye on the northern mode for a potential tornado outbreak, in my own opinion. So that's what we're looking at there. I know that was focused more on the Midwest and the Central Plains, but we haven't really had an opportunity to look at anything in a severe regard here in the Southeast yet. Thankfully, some would say. So we're more than happy to kind of look at things and get my feet wet, kind of looking at that. Ooh, we got SRH is over 200 as well. That's yeah, we're definitely going to have to keep our eyes peeled for that on Thursday evening into Friday. So let's take a look at temperatures. Temperatures going into next week is going to be a significant talking point as well. This is starting out on Tuesday, and we'll look into the next week as well. We see well above average temperatures across the majority of the contiguous U.S. until we get to Thursday and Friday. You can see that surface low start to make its way in, drawing a lot more cold continental air mass, putting us well below average in on the far elevated regions of the plains. Still going to be well above average in the eastern seaboard, and then we'll go further in time here. This is Saturday, Sunday into Monday. We're generally below average across the majority of the east, with the exception of the coastal regions. And then the main story will be actually going into Tuesday into Wednesday. Because this is the Euro forecast for temperatures all the way. Look at this, the freezing layer denoted by that line here. This is at the surface, so well below freezing in areas all along the Midwest, and then dipping down all into portions of Alabama, Georgia, and into the Carolinas as well, across the Virginia Piedmont, and the WPC or the CPC is actually already highlighted risk of hazardous temperatures starting on the 20th into the 21st. For these particular regions already. So that's where we would expect much below normal temperatures according to the CPC. So, in terms, the astronomical last day of winter is technically that March 20th date. So it's going out, our potentially last major blast of cold air for the Southeast. Not going to have anything, unfortunately, wintry associated with it, but a little last chance blast of cold air right at the very end of astronomical spring, potentially on deck for those particular regions, and we'll definitely be keeping an eye on that as we move forward into the latter portions of the week. But that is all that I have for you today. Once again, my name is Zach for Great Atmosphere. I do appreciate you tuning in. I'll be trying to at least do all these videos for you about 3 days a week, Monday, Wednesday, Friday, with the exception of extenuating circumstances that obviously come up every now and again. But I do appreciate your subscription. I do appreciate your attention, and I will see you on. See, now I'm all thrown off. Maybe. Well, I'll try to do one tomorrow. If not, we'll just do Tuesday, Thursday this week. Who knows? We could do whatever we want. All right. Once again, my name is Zach. Great Atmosphere. I'll see you on Thursday. We'll do Thursday. How about that? All right. See you then.